Hey everyone, welcome to this talk. We're going to talk about the Arrow Data Interface today from a Python perspective, and relatedly this Arrow PyCapsule Interface. Now I'm showing you this documentation online because it's there. It's out for you to read. You can go ahead and go through it. It's a little dense, so if you're just starting out, maybe not the easiest thing to get through. I wanted to create this video because I think it's getting easier and easier to build these kind of extensions with Python, and I wanted to share that with everyone. Really, this video is for Python developers that want to either know more about Arrow, how Arrow works at a deeper level, and maybe want to learn how to write more efficient Python extensions, or I think the last camp of users and developers would be people that kind of know Arrow, kind of know extensions, but just want to see, how you can build extensions with Arrow. This tooling has been evolving fast. It's fantastic. So I'm really excited to give this presentation today. Let's jump right in. What I'm going to do is show you how we can create just a new library called PyArrow extension, and we'll jump right in there. Now, again, this is going to be a Python project, so one of the first things that you probably want to do is create a virtual environment, whether you use Conda or virtualenv or something else. It's really not that important. I'll just use VM for now. And once this is created, I'll go ahead and activate it. Source bin activate. Great, I have my virtual environment. The next thing I want to do is install Meson. Now, Meson is going to be our build system generator. The reason why I've picked Meson, you could have, you can build these from scratch. In the past, people would use setup tools to kind of make their own build commands. That's kind of gone by the wayside. CMake is a popular tool, but Meson has been used by a lot of projects in the scientific Python space, pandas, NumPy, SciPy, and it's just a really nice tool. So I strongly encourage you to check it out. So, I need to actually install that now. I'll pip install Meson. And once that's complete, what I'm going to do is install actually nanoarrow. So the way that you do this with Meson is use a subproject. We're going to create a subprojects directory in the root of our project. And then we're going to say Meson wrap install nanoarrow. Now, what this is going to do is kind of set up this wrap file in subprojects, so I can look at that, and the contents of this are not important. Just be aware that that's why we made that subprojects folder. Meson will take care of downloading that for us, placing the subprojects folder, moving the elements out of it that we need into our build folder. Just a lot of things that are kind of annoying. Meson offers a really nice abstraction on top of that. And then the last thing I want to do is just create a source layout for my Python module, so I'm just going to do everything in source/PyArrowExt. Great. So I have this project set up. It's course code PyArrowExt. The first thing that I'm going to do once I actually start writing code is make my Meson build configuration file. And within this, you're going to say things like, what's the name of the project? I'm going to call this PyArrowExt. Which languages does it need? We're just going to do C for this demonstration. Of course, you could write C++ with nanoarrow. We'll leave that to another video. And a couple other things that I just personally like to add here to make sure that I don't make mistakes that I'm not expecting to, because I make them all the time, is to add a higher warning level. I'll do 2 for now, and I'm going to set a higher C standard of C17. That's the project configuration. Next thing I want to do is make sure my project can find Python. So this is how you do it in Meson. You say import Python find installation. If you've used CMake before, it's kind of like the find dependency in CMake, but it's just finding whatever Python you're going to use to build this. Next thing I'm going to do is actually declare the nanoarrow dependency. And the way you do this is use the dependency function here. It's going to search for nanoarrow that we installed as a subproject with the wrap file. And what I'm also going to do is say I want this to be built as a static library instead of shared. Now, we can talk about the differences there at end. Not really in scope for this presentation, but I think generally you're going to find that you want to do a static library build of nanoarrow. Finally, once we have all that in place, we can actually build our extension module, which we haven't even built the source file yet, but we're just stubbing out everything we need. Calling this PyArrow.ext. I'm going to say the sources for this are going to be in source PyArrow.ext, and I'm even going to call the file PyArrow.ext.c. And then finally, I'm going to go ahead and add my dependencies and say this requires nanoarrow dep. So what that dependencies does is it takes any header files or libraries that nanoarrow creates as part of its build and make sure that the headers are included and any linkage is done properly between our extension model and nanoarrow. That's it. The project is set up and we have it stubbed out. Okay, so now that my Meson configuration is done, what we can do now is actually work on the implementation. So remember we created that source PyArrow extension folder. I'm going to go ahead and create this as PyArrow.ext.c. Now, when you first create a extension module in C, there's a lot of boilerplate that you have to kind of go through. That's all in this Python documentation for extending C or extending with C or C++. I'm not going to go through all that because it's a lot and we can make this video really last a long time, but I'm just going to stub out a couple things. Anything that you see to implement is what we'll work on in this video, but everything kind of here and below with these Python module definitions, method definitions, module definitions, and so forth. This is basically just how you set up a C extension. You create this array that contains all these methods, sum array, and in Python, let's just call this sum actually. We'll create a sum function that's going to map back to this sum array function that we implement internally, part of our PyArrow.ext method, and that's all part of the module. So anyway, that's a lot of boilerplate we're going to skip over. We have that done, so what we're going to do is say Meson set up our build directory. Oops. And sorry, ignore that. We'll do a Meson setup build directory from scratch. And you could see that it didn't really have any issues. Found nanoarrow, downloaded it for us. We're good to go. One thing that would be nice with our code editor is to get better support from a LSP or a language server so that all these squiggly lines and stuff can go away. When you use Meson, which uses a tool called Ninja to actually do builds, it creates a compile commands.json file, which is called a compilation database, and your language server probably wants to use that. So I'm going to create a symbolic link to that file, which is in the build directory, to my root directory. And then I'll restart my language server, and great, all those issues have gone away. I have a couple warnings here, things going on, but generally this is a lot more helpful in terms of figuring out errors and getting code completion and things like that. So now what we need to do is figure out how to actually implement this sum array method that we've started off with. So first things first, our method, which allows var args, can take positional arguments. So the first thing we want to do is unpack those positional arguments into an actual Python object. So we could do that by saying this. This is again more the Python language itself, but you say pyarg parse tuple. I'd say the argument that I need to unpack. O means unpack to a Python object, and obj is the object I need to basically extract out of the args. Now, if that fails, we're just going to return immediately. Python takes care of setting a exception, and things are good to go from there. So once we have that, and this gets back a little bit to how the PyCapsule interface works, but if you want to see if an object exports a PyCapsule, you read through this. We're going to look at arrays, and what you'll see in this documentation is that an array will define an arrow C array method if it can export the data we need for this interface. Okay, so we're going to go ahead and try and find that, and what will happen is this arrow C array method will actually give us back a 2-tuple of capsules. We'll talk about capsules in a little bit, but I want to try and find this object, inspect it for a 2-tuple, and make sure we're good to go. So this is where we're going to say PyObject tup equals get arrow array tuple, and I'm going to pass it the object that I just worked with. So let's jump up to this get arrow array tuple function that we're creating. And when we want to look at this implementation, again, the first thing that we're going to do is kind of check if whatever object I'm passing it has that attribute. So this is arrow C array is what we're looking for. And if it doesn't have that method, well, we can pretty much immediately throw an error and return, right? So this would be PyError set string. I'd say PyEXC. This is going to be a type error, meaning I didn't get the type I was expecting. And I'm going to say provided object has no attribute, or no, we'll call it method, arrow C array, right? And this is a good indicator that something has gone wrong to the caller. Once we set that string, we'll return null back from this object in line with standard Python practices for error handling, and be good with it. So the next thing we want to do, we've determined that this object that we're looking at does have an arrow C array method. We're going to go ahead and call that. And this should return back our tuple. So we're going to go ahead and say PyObject call method, and I'm going to, on the object, call that same method arrow C array, and it doesn't need any arguments. It should just be by itself, okay? And if that call fails for whatever reason, we're just going to return immediately. Again, the Python runtime should have set an exception for us, telling us why it failed. If it did pass, we still want to do some more sanity checks and say, okay, is this actually a tuple? And if it is, I need to make sure that the tuple has 2 elements, right? So this is extremely defensive programming. Chances are, if we've gotten this far, we're good to go. But you never know. Someone malicious may decide to implement this method on a totally unrelated object just to try and cause undefined behavior in your program. So always program defensively. And again, make sure that we get here a 2-tuple. If we have not gotten that, then we're going to say arrow C array did not return a 2-tuple. Great. And that's return null. So if we've gotten this far, we've passed our validation checks. We've inspected this object. We've figured out that it is a 2-tuple, and that's good enough for the get arrow array tuple implementation for now. So we'll jump back down to that. Now that we've unpacked this, that tuple contains what are called capsules, right? And let's even do this for now. Let's pip install PyArrow. I don't think we've done that yet, and it'll be helpful to inspect what these look like. But what you'll see with the capsule is it doesn't really look like much in the PyArrow runtime. I'm sorry, in the Python runtime. But it helps you kind of transfer generic void pointer storage across different objects. So anyway, we have an array here just of 1, 2, 3. We'll call that method arrow C. Whoops, I kind of arrow C array. That's what it is. Arrow C array, and we'll see that this does give us back a 2-tuple. We can even inspect the type. It's a tuple. There's 2 elements, and they both contain capsules. Again, a capsule is Python's way of allowing you to share void storage. You basically pass a void pointer and give it some kind of name, and you can see that here we have arrow schema and arrow array as the names of those capsules, right? So this is a good sign. We need to inspect that we get this back and kind of convert these 2 capsules into objects that we want to use in nanoarrow. So this is a good use case for this unpack arrow capsules to views function, which sounds like a mouthful, and it kind of is. But let's talk about this for a second from the lens of nanoarrow. We have this arrow. In nanoarrow, you have arrays and schemas. So the array has the actual data attached to it. The schema has information about that array. what type of array is it? Is it an integer? Is it a record? A struct? All that metadata is attached to the schema. Now the array and the schema are kind of objects that you can create and modify. The views are read-only lenses into what they're doing with a little bit more convenience to understand what's within those arrays and array views. So we want to actually get two a schema view and an array view, because that will be helpful to kind of get a lens into the objects that we're looking at. We're going to create these as structs on the heap and just do schema view and array view. And we're also going to create this arrow error struct, which helps pass error messages along in case they pop up. You never know what's going to happen. Respect the error messages and try and handle them if you can. So the last thing we're going to do here is say this error code equals, oops, that's incorrect. And then I'm going to say, we already have this stubbed out, but unpack arrow capsules to view. So this method that we're going to implement, we'll take the tuple as the argument. It'll take the pointed to the schema view, so we're going to pass that as the address of the stack object. Same with array view, and then finally also the error expects a pointer to that. So let's jump up to this and actually implement it. When we're looking at this is probably one of the more complicated functions to understand, but we want to get those capsules out, right? So we already know that we have a tuple. You could argue we maybe should be even more paranoid and double checking that we have a tuple in this function. I'm skipping that for now, but it's a fair argument, right? But for now, with the function before, I know that we have a tuple that we're passing in. We can see in the Python runtime that the first element's arrow schema capsule, the second's arrow array. We just need to validate that down in our code. So what we're going to do is say, okay, this schema capsule should contain an arrow schema. That's why it's a schema capsule. And the way you do that is you call PyCapsule get pointer with the capsule that you've gotten. You make sure it has the appropriate name, and then you can obviously cast that back. If for whatever reason the name's incorrect, you should get an error message here. So we're going to go ahead and double check for that, make sure everything's okay. If for whatever reason we don't get back a schema, this is a good time to set an error and say could not extract the arrow schema capsule. That's a good way to do it. And then we'll just return a Unix error code, which is kind of, with the PyObject function, we were returning a Python object. Returning null is good. In the arrow space, we're not really returning heap objects as much, so use a lot of kind of Unix-inspired error codes, and the EIN val is essentially a value error there, so we could just add that in. Same thing we're going to do with the other capsule. So this time we're going to look at the second item of this tuple. Tup1. Very good. And same thing, const. We're not really going to modify these, so it's totally fine to make them const. Do that. Cast arrow array PyCapsule get pointer. Same thing. We're going to call that array capsule this time, and we need to look for arrow array as the name of that capsule to be able to completely and confidently unpack that. We'll check for null, and we can just take even the same error message that we had before, but just modify it for array. Nice and easy. So we have, arrow, what did I do here? Typo, that's not good. So like I mentioned, we have an idea of the array and the schema now, but we actually want to populate views on top of that so that we can get a read-only look into the schema data and the array data. So the way we can do this is nanoarrow return not okay, which will immediately return if for whatever reason this fails. We're going to initialize the schema view tied to the schema, and pass it the error message, or the error as well, that it can set a message in case something goes wrong. Same thing, we'll just say return not okay, and for this next one, we're going to go ahead and say arrow array view init from schema. So we've initialized our schema view already. This is initializing the array view. Same thing, set some error messages there. And then finally, what we're going to do is go ahead and try to set the array view to be able to look at the array. So you do this with array view set array. And I'm going to say array view, I want it to look at the array, and again, once we'll pass the error message in case something goes wrong. Now I'm checking if there's an error code that comes out of that, and if I am, I need to kind of clean up this array view that I've created, and then I can return the error code. Otherwise, I'd get a memory leak if I didn't clean that up, so I need to have that there. If I've made it this far, I'm good to go. I can tell the function everything succeeded. So once again, we've basically taken the capsules, we've mapped them to an arrow array and an arrow schema, and then we've created views on top of them that we can kind of give back to the caller so that the caller knows how to navigate those objects. Okay, so we are pretty much there with unpacking. Now we're pretty close to the fun stuff. I mean, this might seem a little pedantic so far, and it's a lot of code to write at first. You know, you don't get a ton of abstractions when you're writing lower level code like this, but we are getting closer. So finally, what we're going to do here, after we've called that, we're going to check to see if we got an error message, and if we did, we're actually going to set a Python error from our arrow error code. I'm just going to pick a type error here. I guess we could kind of debate which type of Python error is the most appropriate, but we're going to go ahead and do that there. And then finally, what we could do is, if we've gotten this far, we're going to say actually do the compute sum, and we're going to pass it the schema view so I can validate the type of data that we're working with, the array view so that I can navigate the data, and that's pretty much it. So now we need to actually implement this compute sum function, which again, this is where kind of most of the fun happens. So what we could do with this is look at the schema view, and the schema view has types associated with it, right? So we're going to say what kind of type of data am I working with, and I'm going to check for a few things. I'm going to look if it's integral, really. I'm not even going to do unsized integral for now. I'm only going to allow signed integers in my expression. So if any of these are true, I can basically go ahead and to-do sum. But if they aren't true, what I could do is fall back to a default that will basically just create a Python message or a Python error. We'll call this a value error again. And I'm going to say can only sum signed integral error types. Okay, that's our limitation for this for now. And if that's the case, we'll go ahead and return a null value once again, which is kind of the Python standard for passing errors. But if we're good to go, we have the right types, we can actually work on implementing this. So I'm going to go ahead and start with a value that's initialized to 0, and then what I'm going to do is start this looping logic. So I'll start at 0 in the loop. We're going to loop until we kind of, what am I doing here? Loop until we exhaust the length of the array, and do our classic increment by 1. So classic C loop, nothing too crazy going on here. So first things first, we want to check each element and understand if it's valid or not. So the easy way to check if something is valid or not is use this arrow array view is null function, which will take an array view and an index, which here is I. And if we end up with a null value at any point, we're just going to continue. We're not going to add that null value to our summation. Doesn't really make sense. It's undefined what that value is, so we're keeping that out of there. But if we do happen to have a value, what we're going to do is say arrow array get int unsafe. So at this position of the array view, go ahead and grab that value and return it as an integer, which will add back to the value. Once that loop is exhausted, what we can do is just go ahead and return our value from a long, and there it is right there. So that's pretty much the function. We need to do just a couple minor cleanup things here at the very end just to make sure we are handling our data correctly. Once we're done with an array view that's valid, we need to reset it. That'll basically release its resources. So I'm going to go ahead and release that array view so it's not holding anything up, and then I'm going to return the result. Whew. Okay, we are done. Hopefully, let's see what happens when we try to compile our build directory. I need to type build directory appropriately. And we have some kind of errors. What did I miss here? I get rid of all these imports at the top. Let's try again. Okay, I don't know what those imports were doing, but they were messing it up. My editor decided to add something there. If we aren't sure, you know, I'll jump into the build directory here, but we could also clean the build directory, and let's just do one more quick compile just to see 7 out of 7 everything's good. So this library should actually work now. Let's see it in action. And we are going to import PyArrow as PA first, and then we're going to go ahead and import our PyArrow extension. And yeah, what we could do, we can create an array, and this is going to be a PA array of 1, 2, 3. And let's go ahead and actually, before we do that, let's check our error handling. And I'm just going to pass the number 42 to the sum function. And we have a seg fault, which is not good. Woof. That's not what I wanted to see. I must have mistyped something. We'll look at that in a second. Let's jump back into this and see if we... presentations never go as planned. Let's see if we could just at least get this to work in the case that we have valid inputs. Okay, so we have 6 there, and then you know, if I added none there, it's not really going to impact anything. So yeah, you can see this works. It's relatively performant. We're not necessarily going to be faster than what you get from NumPy, or I'm sorry, PyArrow directly, but it's going to be reasonably well performant. And again, your goal is not really to re-implement sum. If you decide to go down this path in the future, you are trying to build your own algorithm. So this is as, you know, high performance as you can get without diving into the internals of how data is laid out in Arrow. I guess one last bonus. I really did not want to do this in this call, but I have some kind of error message here. So what we could do with Meson is actually set up our project to use sanitizers. So I'm going to do this with the bsanitize command equals address and undefined. So I obviously did something wrong. And what you could do here is, this is quite a lengthy command, but if you have asan on your system and you can kind of get that, that's part of LD preload, and if you use malloc for Python malloc, depending on your Python version, you can actually get asan or ubsan to work. Now, each Python version is a little tricky. Sometimes they don't work that well, but we'll try it here and see how far we can get. And sometimes you get weird issues like that. So let's just try this again. I guess we don't even need to import PyArrow. We could just do PyArrow ext.sum42, and you could see immediately that we have some kind of asan issue, and it's in the sum array and unpack PyArrow capsules views. So this is interesting because I would have expected we should have failed much sooner in that process. We shouldn't be getting down to unpack arrow capsules to views with sum array. We should have thrown an error by the time that we tried get arrow array tuple. So something here is not correct. I must be missing error checking, and there you go. Look at that. So we're going to say if tup equals null, we should just return tup immediately here. That is, yeah, not something that should be happening. And yeah, that'll that'll help. I guess the other thing here that we're missing is definitely yeah. I'm just looking at this for now. We need the py-decref arrow toop. So this is probably a good example why you might not want to use C as a language. If you're missing these py-decrefs and you're missing small things like that, you can have potentially serious issues in your program. So it may be a good reason to use C++, which we'll talk about next time. But for now, it serves as a good example to see what we did wrong and how to catch that. So now we do the same thing. There is a error message that probably should have had two trailing underscores there, a little dunder at the end, and meant to do that there as well. But now we actually have the right error message. If I quit, I didn't get any kind of issues with ASAN or UBSAN. So anyway, thanks for watching. That was a lot of fun to go through. I know that was a lot of content as well. So don't worry if you didn't get everything. It's a lot to get through, but hopefully you could see how even starting from scratch, you can get to a place where you could start writing these algorithms, working with Arrow C data and capsules to send data from the Python runtime down to your extensions. Happy coding, have fun.